Guys, today I'm going to introduce you to the Holy Moly lab. Obviously it's going to be a little bit lame because I can't actually give you samples and have you measure them. I have made some data for you to analyze. It's going to help you practice and understand molar mass a little bit better, hopefully. This lab is also known as the Molar Mass Lab, the Mysterious White Substance Lab, and has been affectionately nicknamed the Cocaine Lab by many students in years past. There's actually no cocaine involved. That would be illegal. Okay, so in this lab, ideally I would give you 7 bags. Each bag would have an unidentified white powdery substance. Written on the bag would be the number of moles in the bag. So you know how many moles are in there, but you don't know what the substance is. So by finding the mass in grams, and you already know the moles in moles, you can divide grams by moles to find your molar mass. So it's pretty straightforward. And it's a really elegant way of relating molar mass to unique substances. So as you're writing your purpose and planning section, remember to explain what molar mass is. How do we find it? Why is it unique to different substances? And why is it really useful to us? And describe how you would complete this lab if you were doing it in class. So write the procedure. So we would need the 7 unknowns, we would need an empty bag, we would need a balance, we would need to find the mass of the empty bag, we would need to find the mass of all the bags with the unknown powders, and so on and so forth. If you have questions about different pieces of that procedure, since you don't get to actually do it, definitely just ask me and I'll help you with those. A little more information for your planning purposes. The 7 unknowns are these 7 compounds. We just don't know which unknown is which. So one of the bags is calcium acetate, one of the bags is calcium oxide, one of the bags is potassium sulfate, one is sodium acetate, another is sodium carbonate, one is simply sodium chloride, table salt, and the other is zinc oxide. I should mention at this time that if we were doing this in class, you would not be allowed to open any of the bags. And even though sodium carbonate and sodium chloride have a really unique taste that is recognizable to most of us, sodium carbonate is baking powder, and then sodium bicarbonate is baking soda. So they both have that kind of bitter taste. Anyway, no tasting the chemicals. The information you're going to have to collect includes the mass of a bag without a sample. I've provided that mass for you. The average Ziploc bag weighs 2.1 grams, so use that value. You're going to need to know the mass of each bag with the sample. You need to know the number of moles, which is written on the bag, and you need to know the molar masses of the possible unknowns. So part of your planning section is to calculate the molar mass of all 7 of these unknowns. Please show your work. Okay, you could Google these, and maybe you should to confirm your answers, but you must show your work that you know how to calculate molar mass using the periodic table and a molecular formula. Okay, so please, please, please include the calculations in your planning section. So show at least one calculation, then list the molar masses. Please use units and labels for all of your calculations so we know what each one is. So even if you don't show all 7 calculations, you need to show 1 all the way worked out. Okay? This table provides an image of each of the unknowns. So You can see that they are all white, and some of them are more powdery, some of them look more crystalline. You might be able to make some tentative predictions based on the appearance, but really overall it's very hard to tell these apart simply by their appearance and texture, especially because most of these compounds can be ground into really fine powders, and they would all look identical in that case. So I provided these images so that you could write a description of each unknown, which you should do in your data table, and give you a little bit more of a feel for what you're measuring. All right, so here's the data that I've provided for you. You should recreate this data table in your notebook or in your document if you choose to do this online. You've got data for your 7 unknowns. I told you the mass of the bag and the unknown. So this is just raw data, like what you would get if you set the baggie on the scale and then took it back off. I gave you the number of moles written on the bag. And then on the far right column, it says write a description of the unknown based on the images in slide 5. So you should write a brief, detailed description. And if there's something that makes it stand out from the other white powdery substances, you should note that. Or maybe there's another unknown that it's very similar to, you could note that as well. All right, in your data analysis section, you need to calculate the mass of the substance without the bag. Then you need to calculate the molar mass of the substance found in each bag, right? So mass of substance without baggie divided by number of moles written on the bag will give you grams per mole. And then you can use that value to match it to the molar mass of one of your list of unknowns. Okay, please show your work for this. It will be really important that I see that you have gone through and done this practice. And it also allows me to be able to tell if things have gone wonky for you, right? I can figure out why that happened and help you get back on the right track, okay? In your evaluation, very typical evaluation, but make sure you identify which unknown number is which substance. Something I've noticed in our evaluations is we might identify an unknown or answer the question of the lab in the data analysis, but we don't restate it in the evaluation. And it's really meaningless if we don't summarize our findings in our evaluation. So you'll need to list out in your evaluation that, you know, unknown number 1 was sodium chloride. And compare your experimentally found molar mass to the theoretical mass you calculated. So, you know, are they dead on? Is it close? Is it within rounding? You know, normally I ask you guys to think about possible errors in the lab. Since you didn't do this lab, you don't need to worry about that as much. However, if you want to theorize about some places where this lab could go wrong, you are welcome to include that. Yeah, so a little bit weird, a little bit unconventional, but we're just going to make it work the best we can. Please post any questions that you might have about this. I think I'll make this lab due on Tuesday of next week, and that way we have lots of time for you guys to like look at it, start to work through it, ask me questions on Friday, ask me questions on Monday, and then I'll have you turn it in by the end of the day on Tuesday. Okay, so that's the plan. Thanks for listening, and thanks for being amazing, you guys. I'm super proud of you. This is so unconventional. And you're just really taking ownership and crushing it. So good job, my dears. Bye.